So let's talk about section 3.2, solving quadratic equations. Now, one of our objectives is basically we're going to learn the different methods for solving, and there's multiple methods for solving quadratic equations. Please understand, as you can see with all the objectives here, there's a lot of different methods, and a lot of this is going to depend on your next step in your math journey, and some of it is going to be a little bit more beneficial in a future class than it may be currently. So we're going to start with the factoring method, and this is one of my favorite methods, and I'm going to say this because, again, I have gone on this math journey and I love the factoring method because of how useful it was for me. Now, with that being said, with the factoring method, the first thing that we have to do is we need to make sure all of our equations can be written in the form ax squared plus bx plus c equals 0. Now, we say it this way because when it equals 0, that will actually help us. However, we also have to make sure that it's quadratic. If it is not quadratic, then there's no point in trying the factor style method. Anything that's quadratic or higher will be a possible quadratic, or something higher than it could be factored. If it's linear, which we spent a bit of time learning about linears already, there's no factoring in that. Okay, so we might be able to factor out a GCF, but that is not going to work with the full factor method. So in order to use the factoring method, we want to make our quadratic equation equal to 0, and then we also want to employ the zero product property. Now, the zero product property basically says that if you have the multiplication of two real numbers and it equals 0, then at least one of those numbers has to be 0. And this is basically the rule that we're going to use, except for more algebraic style, in saying that these two numbers that are being multiplied are also known by the name a factor. So let's start by solving the following quadratic equation, and let's use factoring for our method. So we have 3x squared plus 7x equals 6. Now again, remind yourself that I started off with saying, hey, one side needs to equal 0. So we're going to start by subtracting 6 from both sides, and we're going to rewrite the equation with 0 on one of the sides. That's going to give us 3x squared plus 7x minus 6 equals 0. Now, just kind of a little sidebar here. Does it matter which side I move all the items on? Absolutely not. I keep saying one side. I am not specifically saying left or right because it doesn't actually matter. However, I do have a personal preference, and my preference is to basically make sure that the a term, that would be the item that is attached to the x squared, is positive. If a is positive, it makes work a little bit easier later on, especially if you have trouble with signs. Now, how do I know which one is the a term? Well, guys, do remember that just on the previous slide, I talked about this ax squared plus bx plus c equals 0 was our basic format of a quadratic equation. That a is always attached to the x squared. Now, with factoring, I need to start with that AC number. So that AC number is going to take the A number and the C number, so that's 3 and negative 6, and multiply them together, which is going to give me a negative 18. And then our B number, which is 7. So what we want to do is we want to find two numbers that multiply to be the AC number, but add to be the B number. Now, again, for those of y'all that can go through the trial and error method really quickly in your head, that's perfectly great, and you can see the factors. For most people, they don't see the factors unless they try a pattern, and this pattern is called that AC method, and it's a real great way to practice, just kind of making sure you know the factoring rules and regulations and all that. So I noticed that my two numbers are going to be basically 9 and negative 2. Positive 9 and a negative 2 will multiply to be negative 18, but they add to be 7. So what I've done is I went ahead and I rewrote, I rewrote that B term, that 7x, as the two numbers that I found that worked well together. So I rewrote them to where it is no longer 3x squared plus 7x minus 6. It's 3x squared plus 9x minus 2x minus 6 equals 0. So I haven't actually done anything to change the problem. It's still equivalent to the original problem. All I've done is I've broken b apart to work how I need it to work. Now, the reason why I did it this way was because I can take the first two terms and pull them together, and I can take the second two terms and pull them together, and I can factor something out of both of them. Now, out of the first one, I can pull out a 3x, and the second one, I can pull out a negative 2. And when I do that, I pull out what we call our greatest common factor of those two items. And so the first one I'm pulling out a 3x, leaving me with an x plus 3, and the second two I'm pulling out a negative 2, and leaving me with an x plus 3. At this point here, I notice now that both of these share a common set of parentheses. And so what I can do now is I can factor out that common set of parentheses. And what's left in front of those parentheses is going to be the other factor. So there's my common factor factored out of the whole thing. And then what's left in front, so let's highlight what's left in front. We'll use a different color here so you can really see it. Ooh, that's a little dark. How about, we'll go with blue. So as you can see here and here, what's left in front became the other factor here. Okay, now, why do I want these in these beautiful factors? Well, again, remember I said factor is just another way to say two items that are being multiplied. Notice they're both in a set of parentheses. They are multiplied together and they must equal 0, which means by the zero factor property that either one of those equals 0 or both of them equal 0. So I can say 3x minus 2 equals 0, and then I can set that x plus 3 equals 0. And now I have two linear equations that I can solve, and we're going to get x equals 2/3 and x equals negative 3. So let's start with this one here. So we have the height of a ball, and this is a word problem. That's perfectly fine. So the height above ground of a ball thrown upward 64 feet per second from the top of an 80-foot building is modeled by the following. S of t plus equals 80 plus 64t minus 16t squared. Now, t is going to be the number of seconds after the ball is thrown. How long will the ball be in the air? So one of the first things you're going to notice is that I've already given you an equation. Okay? Since I've already given you an equation, that's actually really important to note. I don't have to make the equation up. However, I had enough information to say what everything was. Okay? So I'm going to kind of point out these little things that you may not have noticed, but I noticed straight away. So 64 feet per second, that is the velocity. That's going to go right there. I also noticed pretty straight away, it talked about we start my initial height at 80 feet per second. So this is actually one of our base formulas. It actually is a formula dealing with height. Now you're probably going, well, where did the 16 come from? Well, that's minus 1/2 times g, which is gravity. And gravity is going to depend on whether I'm using feet or meters. And because I'm using feet, we know that our gravity is actually 32 feet per second squared. Feet per second. That's gravity, like it's just known. If you're using meters, it's a 9.8. And so with the formula being a negative 1/2 times that 32, that's where the 16 came from. If I was using meters, then I would say a negative 1/2 times a 9.8. Okay, so the question is asking how long will the ball be in the air? So we're going to start by basically taking that equation and setting it equal to 0. Now, if we set time equals 0, that's t is time, we get our initial height was 80. So we're starting at 80. So we're 80 feet in the air already. So if I'm talking about how long will the ball be in the air, I want to know when it reaches the ground. So thus, when does S of t equal 0? So we can solve this by basically taking that beautiful quadratic equation and setting it equal to 0. So to continue with that idea, what we're going to do is we're going to need to basically start solving. Now, again, I warned you earlier, I don't like having a being negative. So I did happen to notice that a negative 16, a 64, and 80 all share a common factor of 16. And again, I really don't want that a number to be negative. So I'm going to also divide out on all sides by a negative 16. So that leaves me with 0 equals t squared minus 4t minus 5, which is so much nicer. Now, this is actually where it's going to get really fun and interesting. And I know you're like, gosh, she likes math. So, of course, it's fun for her. For me, it's actually more about the puzzle. So for me, I'm noticing straight away that my A term here is 1, my B term is negative 4, and my C term is negative 5. So I'm going to take and get my AC number there, and my AC number is negative 5, and my B number is basically negative 4. So what two numbers multiply to be negative 5 but add to be negative 4? Well, if you think about it, it's actually just what the AC numbers are. So in my case here, I can factor super quickly, and I can do this one very, very quickly because that A term being 1, I can go straight into the two factors and get t minus 5 and a t plus 1. Set each one of those factors equal to 0, and then solve it out, and we get t equals 5 and t equals negative 1. At this point here, I'm looking at t and reminding myself t is time. So since t is time, it makes no sense to have t equals negative 1. So only the positive values in this application will have meaning. So basically we know that it's going to take 5 seconds after the ball is thrown for the ball to actually hit the ground. So it's going to be in the air for 5 seconds. Now with profit, same problem, except for what's different is the style of questions that we're asking. So consider daily profit, and daily profit for a production company for the following, where it has X units being sold, is given by P of X is equal to a negative 0.01 X squared plus 20X minus $500. Now we're going to use the graph to find the levels of production of sales that gives a daily profit of 1,400. Now again, I'm kind of telling you what method to already use, but what I'm noticing is when the profit equals 1,400. Now remember, I said the formula basically is equal to profit. So in our case here, this would be a great case to use the intersection method. So we can basically solve it out algebraically, or we can use the graphing calculator. If you're going to use the graphing calculator, which I would recommend with this one, it does mean that you will need to adjust your window. And if you are not as familiar with adjusting your window, then go ahead and take the algebraic method, the by hand method. Okay? But in order to work this out with the calculator, basically we're going to put the equation in y1, and we're going to put the what should it equal in y2. Okay, so now that we've put it in the calculator and we've had to adjust our window, we notice that our first adjustment of the window is probably going to work best if we say going from 0 profit to say something quite high. Now you're probably going, well, I don't know how I need to know where it goes. Well, we know that we're looking for where it equals 1,400, so it's got to be above that, so at least above 2,000. But when you do that, you're going to notice that you're not going to see the top of the equation. So what's really, really helpful here, especially something like this, because it's quadratic, which means it's that parabola shape, it's going to go up and then come back down. I might need to see a second spot where it hits. And so in order to help me with that, I would strongly recommend the vertex to help you there. So if you notice on the vertex, we get the vertex is at x equals 1,000, and our y part of the vertex is going to be 9,500, which means that I'm going to want to go ahead and make my adjustments to my window to have the upper bound be somewhere above 9,500. So how about 10,000? And then because I know my X value of the vertex is pretty much 1,000, I'm going to need to make sure that I'm going from at least 0 to something above 2,000. And it doesn't have to be much above 2,000, but just that idea to kind of help you out there. Okay, and when you do that, you see that you have two places in which you can see it, and we can see there using the intersection method of our graph, we can see pretty clearly that we've got here at 100 and here at 1,900. You are going to have to do the intersection method in the calculator twice to find that. Okay. So with this idea, let me ask a secondary question. My secondary question is basically to ask, is it possible to have a profit that is greater than 1,400? And the answer to that is yes. We again saw pretty nicely there that the vertex was above the 1,400. So with this, yes, it was completely possible, and it happened to be above 1,400 after it passed those two intersections. So let's talk about combining graphs and the factoring. So with combining graphs and factoring, the first thing we need to talk about is the factor theorem. And the factor theorem is basically just another fancy way to talk about the zero product property. However, this is going to be more the style with the algebra side of things. So the polynomial function, whatever polynomial function you have, has a factor of x minus a if and only if f of a equals 0. If that is the case, thus x minus a is considered to be a factor of f of x if and only if x equals a is a solution to where the function equals 0. Now I know that sounds really strange, but it'll make sense. So let's start with an example so it actually makes sense. So we're going to solve 0 equals 3x squared minus x minus 10 using the following steps. The first thing we're going to do is we're going to go find one of the x-intercepts of the function. Now, in order to find the x-intercept of the function, we learned back in previous sections that any x-intercept is when that function equals 0, and then you solve for x. Now, in the case of linear, we can totally do that, pretty straightforward. However, with quadratics, sometimes we have all these different methods. So this one, we're going to use the graph first. So we're going to graphically find an x-intercept. We're going to verify that it worked. And then we're going to use the method of factoring to get another solution. So I'm going to plug it in my calculator. So remember, you're going to plug in 3x squared minus x minus 10 into the calculator. You may need to make adjustments to the window, okay? And when you do, you're going to hit second calculate, okay? So on my calculator, what we're doing, again, we are kind of working our way through this, is I am going to hit the button and I'm going to hit second button. And then what that calculate is, and this is where I think a lot of people make the mistake, is the calculate menu is above the word trace. This is why we have to hit the second button first. So second trace is basically going to get us to the calculate menu. This is for calculating on a graph. Now, you can't really use this with anything else unless you have a graph visible. So on that option, you're going to see a few different options. And one of the very first ones that you see is value. We don't care about the value. We want to know specifically where the x-intercept is. Now, on your calculator, it doesn't actually call it x-intercept. It gives it a different name. It calls it 0. Okay? So when you're looking at it, and I'll hold this up here so you guys can see it. So when you're looking at it, you want to look for the one that says 0, which is option number 2. So number 2 is going to happen. And when you select number 2 there, one of the things that you're going to want to do is you are going to want to make sure, and again, this is where you have to kind of work your way through the problem a little bit here, okay? is we want to make sure that we can see where the x-intercept is going to possibly be. And in our case here, that is going to there's two options that you're going to see. I would suggest, and again, this is just a suggestion, that when you're kind of making the option to go for one, go for the one that looks like it is exactly on the line first, and that's going to probably give you the better option there. So if you'll notice, again, I'm pointing out here, this one doesn't land perfectly on a tick mark, and this one looks like it does. So we're going to go for this one first. Now you can try for both, that doesn't matter. But once you hit that second trace, number 2, you're going to see something that looks like this. And what I want you to point out is down here at the bottom, okay? So down here at the very, very bottom of the calculator, it's going to ask a series of questions. The first question is going to be left bound. And what we mean by left bound is we need to actually take a look at the graph, and we're going to say, hey, I need to only look between here and here. So I'm going to actually move my marker to here. So what that's doing is that gives me a left bound. And in order to make it move to the next question, you just hit enter. You don't have to be perfectly close, just get slightly to the left of it and hit enter. And then, as you'll notice down here, it will say, well, what's the right bound? So at the right bound, I'm going to take my cursor, I'm going to put it here, and then I'm going to hit enter. And so what that's doing is it's creating this kind of field of vision for the calculator to only look in this area. Now you're going to have one last question, and again, down here at that very bottom, down here is where you're looking on your calculator, and it's going to say guess. Now your guess, I would suggest, again, try, please try your absolute best to get it on. It's not going to have to be perfect, but put your guess as close as you can. So if it's like slightly down here, that is perfectly okay. And then you're going to hit enter. And then once you hit enter, all of this is going to go away, and it's going to say 0. The moment it says the word 0, you've done everything you need to do, and we pay attention to these items down here now. So we look at that beautiful x equals 2 and x equals 0. This is what we call the x-intercept. Okay. Now, again, it only found one of these. So there is still one here, but we do not know what it is. It's still missing. Okay. So, but I'm going to take a guess that that's not a really pretty number one. So, and what I mean by it's not a pretty number, it's not a terminating decimal possibly. It could be something like 0.33333. It could be a 0.6 repeating. It can be just 0.1234789643245. Like it may not even have a pattern. Like it just, you don't know. If it looks like it falls directly on a tick mark, then that's the one you want to look at. Okay, so now we're going to verify this algebraically. And how do you verify it algebraically? Literally just plug it in. So you're literally just going to take the 0, or aka x-intercept, that number 2, and everywhere you see x in the equation, here and here, you're plugging 2 in, and you're going to end up getting some number to where you'll see that that y value is 0, which is exactly what I want to see. So we know that the calculator actually did find a correct answer. Okay, so now we can go forth and find our secondary factor. So we're going to use the method of factoring to find the other factor here. So since x equals 0, I can guarantee x minus 2 is a factor. Now you're probably looking at me going, how the hell does she know that? Well, guys, remember I said x equals 2. If you work it backwards, you get x minus 2 equals 0. Okay? In the factor theorem, it says that it's x minus whatever that 0 number is. But if you actually look at it algebraically, it's literally just working your way backwards. And this is where that factor x minus 2 came from. Okay? Now, here's the other thing I have to work on. I need this to basically multiply out to where my AC number is going to be 30. Okay? And my B number, negative 30, sorry, and my B number is negative 1. Now, you can still do this all by hand, but we can actually work our way backwards with the factor already set. So with our factor already being x minus 2, we know that our other factor there is going to be x and then some number. Now, I know x is going to be here, but here's the fun bit about this. These two numbers, when we multiply them out, whatever they may be, this one, which is guaranteed to be 1x, and this one have to equal this. Okay, like it has to. It's automatically, that's kind of a given statement, which basically tells me straight away that this has got to be 3. Now you're going, how the heck does she know that? Well, if this one's guaranteed to be 1, 1 times what is 3? 3. So done. Work is done there. Now the other thing that we can work, again, working backwards here a little bit, is that we know, again, as we are looking at this, that this number and this number, when they multiply, okay, those two happen to equal this one. It's guaranteed every time. So it's the FOIL method basically is first, outer, inner, last. The first two have to multiply to be the first number, and the last two multiply to be the last number. But it's that O and I of the FOIL method that gives me the middle number, and that's where we have to do kind of our little sneaky AC method part. But to work backwards this way, we can totally do it. So what two numbers multiply to be negative 10 when I guarantee one of them is going to be negative 2? And again, I've guaranteed this one is a minus 2. So what do I have to put here in order to get me a negative 10? Well, let's think about this. Automatically, 5 times 2 is 10, and this is already minus here, so this one has to be positive. Okay, so we've now figured out our factor. A little bit nicer, neater there, that it has to be 3x plus 5. And since that means the other one, the other factor that we didn't solve that was on the calculator we could see, but like I said, it wasn't going to be a terminating decimal, was a negative 5/3. Which again, may be a little bit harder to see in the calculator. So the two solutions that you're going to get with the combination of doing the graphing calculator, we got x equals 2, and then using that to help us with the factoring method, we got x equals a negative 5/3. Okay, so let's talk about the square root method. Now, the square root method is a great, quick method. Now, with the square root method, there's some good and bad to this. The first thing is when you do the square root method, the first thing is you have to notice it's got to be x squared equals c. Now, c is going to be basically just normally just a number, okay? And when you take the square root of it, it's going to be plus or minus the square root of that number. You must use the plus and minus. If you drop the plus or minus, you're going to get a wrong answer, because when you take a square root of something that's already squared, that x value or that thing that is being squared can be positive or negative. So it's very important that you give both options, the positive and the negative of the squared c. The square root of c. So let's try this out. So let's do 2x squared minus 16 equals 0, and then let's look at x minus 6 quantity squared equals 18. Both of these are great, perfect for the square root method. Now, on part A, the problem in part A, yes, could I use other methods? Absolutely, totally can. But I would recommend the square root method, and the reason why I would on this one is because what happened to bx? It's not there, and that's why this one makes it a great square root method. So we start by basically taking that one, and we're going to add 16. Once we add 16, I'm going to divide by 2, and now we're left with that perfect x squared equals a number. So since x squared equals a number, we're going to get x equals plus or minus the square root of 18. Now, pause for a second and remind yourself, you cannot type in plus or minus the square root of 18. We are not done simplifying. And in math, we always like things to be fully simplified. So I want to make sure that with this one here, that I take the square root of 18 and see if I can simplify it further, which you totally can. And in our case here, it's going to be plus or minus 2 square roots of 2. Okay, if you're a little unsure on this, look for the supplemental videos that talk about this, but this is kind of where prerequisite knowledge is going to come in a little bit here, and that would be really helpful. If you have some type of, some of the lower scientific calculators will actually take the square roots and simplify them for you. Sadly, the TI-8384 does not, and the Casios don't either. The high-level Casios, they had to take something out to make room for something else. Okay, so let's look at the second one. X minus 6 quantity squared equals 18. Now, this doesn't look exactly like the principle of the square root property that I was talking about, but it does meet the requirements. And you're probably going, well, I don't know. Well, it does, and here's why. Remember, I said basically it's something squared equals some number, right? So even if it's stuff inside, instead of just being x squared equals that constant, it can be stuff. X can be anything. It doesn't matter. So, and that's the case here. We can still just say that the stuff equals plus or minus the square root of whatever that constant number is. So in my case here, I can say x minus 6, do not change the stuff inside. It stays exactly as is. But it now equals plus or minus the square root of 18. Now again, hopefully everybody's going, oh wait, 18. 18 is divisible by a perfect square, which means that radical will simplify down to plus or minus 3 square roots of 2. Okay, but I still haven't solved. I don't have x equals. And I notice that basically now I need to get rid of the minus 6. Now, if this was just a regular normal problem that I was solving, and what do I mean by that? I mean basically if this was x minus 6 equals 3, we would add 6 to both sides, right? Now, the problem is I'm still going to add 6 to both sides here. However, I cannot add 6 to this, okay? I cannot add it because I don't know if I'm adding or subtracting the 3 square roots of 2. So because of that, what we're going to do is we're just going to add that 6 over and put it in the very front. And so we get 6 plus or minus 3 square roots of 2, and we're good to go. That's it. That's all you need to do, and we're good to go there. Okay, so let's do one more example, and let's solve this equation by completing the square. I'm going to go through this one pretty quickly here, and I'm going to kind of just more likely just show you instead of walking you through all the different steps. For those of y'all that are on the track to head towards a calculus style math, learn this method. If you are only heading up to, say, college algebra or trig, and that's the highest level of math you're going to get, and then you're going to go into a more specialty field like accounting or business calculus or nursing or elementary education, skip this method, okay? Listen to what I have to say first, but don't put so much emphasis on having to learn this one. There are other methods that you can use to solve this one. Okay, so with this one, the first thing you want to do is you want to basically take the 7 and move it to the other side. We're going to take the 7, move it to the other side here. And again, the complete the square method does not need the one side equals 0. So this is kind of where this one's a little unique. And then we're going to add in a number on both sides here to basically do what we call complete the square. And that number, you're probably going, where did she get plus 36 from? Well, I got 36 from basically taking that B number and dividing it by 2. And then, so 12 divided by 2 is 6. And then 6 squared is 36, and so that's why I added 36 to both sides. The reason specifically for doing this is because when we have this right here, this is what we call the perfect square trinomial, which always will factor out to be an x minus 6 times an x minus 6, which worked out perfectly as the same factor twice. So I can basically write the factor one time and put a power of 2 on it. And so we get x minus 6 quantity squared equals 29. That means I can now employ my principle of the square root property. And then so I can, once I've done that, that removes the power of 2 on that x minus 6. and then we can just add the 6 over, and we're going to get x equals 6 plus or minus the square root of 29. Okay? Again, if you want to learn more about this, please go YouTube it, but for right now, we're good to go there. Okay, so let's talk about our favorite formula ever, the quadratic formula, which I know majority of students still remember the quadratic formula. Now, you might remember it more by a song. It does happen to go very well to Pop Goes the Weasel. It also goes to YMCA. So take your pick. Go hit up YouTube and look for the quadratic formula song. Go ahead and play this one on repeat because this is probably one of the few formulas I will say carries over into almost every style of math. We don't look at it too much in elementary statistics, but in college algebra and trig and calculus, Cal 1, Cal 2, Cal 3, like this one likes to come out and just pop out of nowhere. Okay. Now, if you go into higher levels of statistics, yes, this does possibly show up. Now, the quadratic method, basically, the quadratic formula is the for sure method. This will work every single time. This is why this one's so fun and amazing. So as long as you have something that is quadratic, ax squared plus bx plus c equals 0, I can guarantee you can use a quadratic formula. You need to start by identifying what a, b, and c are. A is always going to be the coefficient on x squared, b is always going to be the coefficient on x, and c is always going to be the constant. Now do remember that b and c are allowed to be 0. So those two numbers there, a cannot be 0, but b and c are allowed. And once you have those, you just basically plug them into the formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, if the equation does not say equal to 0, you cannot plug into this formula. Okay, so make sure that you have that down before you start that next process. So let's solve the following equation using the quadratic formula. So we're going to solve 6 minus 3x squared plus 4x equals 0. Now, our first kind of idea with this one that a lot of students kind of make the mistake on is they do not see it in that ax squared plus bx plus c format. So when you're looking at anything that is quadratic, we always want it to have this base idea as ax squared plus bx plus c, and then it needs to say equal to 0 when I'm starting to use the quadratic formula. So in our case here, what might be helpful is to rearrange it and put it in what we call that standard format. Now that standard format would mean that we would have negative 3x squared listed first, then plus 4x, and then plus 6. What this does is this allows me to identify a little bit easier what a, b, and c are. However, do I need to rewrite it? Absolutely not. But it does make it easier for me to see what a, b, and c are, especially for those of y'all that are struggling with it. Once you've identified what a, b, and c are, you're just going to plug them into the quadratic formula. Now, a couple of rules and regulations to kind of guide yourself by is that when you're looking at your quadratic formula, the formula itself is negative b. So please understand that currently my b is positive 4. So that's going to change its sign to become a negative 4. So that's why that negative 4 is listed there. And then it's plus or minus the square root of b squared minus 4 times a times c. All of that is divided by 2 times a. So the first thing I like to remind students when they're doing this is when you are plugging in, you need to make sure that you are plugging in that b squared with parentheses around it, because one, if you put it in the calculator without the parentheses, it's going to give you a wrong answer, especially if it's a negative number. But number two is basically, as long as you're plugging everything in with parentheses, you are actually on the right track to make sure your math is correct. Now, from there, you're going to only, and this is the part where students make mistakes, so I want to make sure that I am very, very clear, only take what is directly underneath the radical, okay? So only this. So take 4 squared minus 4 times negative 3 times 6. and that's going to give you 88. If you try to put all of this in the calculator at one time, the first problem you're going to get is the fact that this is the square root of some number. And for majority of this homework, it is asking for what we call an exact answer. And so that's going to create this huge issue. The second thing you want to do is you want to make sure that you have multiplied out the denominator. So go ahead and take these two together and get that -6. Okay. Now from there, you're going to slowly check the radical. Now make sure that the radical is not divisible by any perfect square. So if you think about it, 88 is actually the same thing as 4 times 22. I can take the square root of 4, which is 2, and that's why it came on the out. Okay. Now, again, you have to be really, really cautious. So now once you've simplified the radical, the next step is you're going to look at everything directly in front of the square root symbol, directly in front of the plus or minus, and what's underneath, okay? So this is, I know I highlighted it, but I normally like to make it in the V shape here. So you're checking this area. If all three of those share something in common, you're going to factor it out. If all three do not, you're going to leave it alone. But just so you are aware, a lot of math programs don't like having the negative in the denominator. So a lot of times they are going to ask you to go ahead and pull that negative out of all of those. And guys, when you take a plus and pull out a negative, it becomes a minus. And when you take a minus and pull out a negative, it becomes a plus. So that doesn't really make a huge difference for what's in front of the radical, but it will make a difference in front of that negative b. Okay. So if you'll notice there that once I simplified it out, okay, they all shared a common factor of 2. And that basically, that 2, as I divided out of all three of those items is, and I'm going to do it as a negative because, again, I don't really like that negative in the bottom. That's why it became 2 plus or minus the square root of 22 all over 3. Now, that is basically what we call an exact answer. Now, with your exact answer, that is this. That is what we really kind of want to see. However, we can have what we call an approximate answer. Now, at the point that you have gotten the exact answer, and it's as simplified as it can go, then you can plug in and get what the approximate answer is. Now, when you plug it in, so just a reminder that when you're plugging it in, you're going to have one that is going to have the plus sign, and you're going to have another secondary option with the minus sign. Please make sure that when you're doing this that you put the entire numerator on the top. In parentheses, if you have a TI-83. If you have a TI-84, make sure, 1, that it's been fully updated, and 2, that it has the ability to write things as a fraction. Okay? So if it's been fully updated, it should have everything as being able to write it as a fraction. So let's look at word problems with our solving using quadratic functions, and let's see how we can maybe work our way through it. So we're going to use data from the years 2020 projected to 2025, and the number of millions of 5G smartphone users, script subscribers worldwide for the years can be modeled by the following function. S of t equals 54.5 t squared minus 250 t plus 1.0. Now, t is equal to the number of years after 2020. We're going to find the year after 2020 that the number of 5G subscribers worldwide will equal 2.951 million. Now, when I'm looking at this, just kind of idea-wise of like what's going on here, I'm going to notice that I have a word problem, but I also notice straight away that I have this function within the word problem. Now, within the word problem, I also notice that I have kind of defined out what t is, and t is the number of years after the 2020. I also noticed that when we talked about the function, okay, it can be modeled by, and that right there kind of was the keyword to let me know that the stuff that came before it, so the number of millions of smartphone subscribers worldwide, that is what S of t stands for. So when we are talking about this one, especially here at the end, it says find the year after 2020 that the number of 5G subscription subscribers worldwide will equal, okay, there's my keyword right there that I really want to pay close attention to. It says that it will equal this many, okay, which is 2.951 million. Now, again, I noticed that when I was looking at my problem right here, it talked about basically the function represents millions of smartphone users. So with that being said, we're basically going to take that equation that they've already given us and set it equal to 2.951. Now, I don't need to worry about the word million because it's in the model itself, as the model is predicting it in terms of million there. Okay, so I don't have to be super cautious with that. But what would be helpful is, again, just kind of making sure that those units will match. So if one said, say 6,000, I'd have to change the 1,000 into million before I could make this work. Okay, so now that I've set them equal, I begin to notice, hey, that looks oddly quadratic. And since it looks oddly quadratic, we can use the plethora of different methods that we've learned. We've got algebraic, numeric, and graphical. So with this one, let's go ahead and solve it using the quadratic formula. Now with the quadratic formula, what's going to be super helpful is remind yourself that in order to use the quadratic formula, you've got to make one side equal to 0. And if it doesn't equal 0, then we need to do a little bit of work. Okay, so I've gone ahead and made one side equaling 0 by subtracting the 2.951 from both sides of the equation, and that's how I got it equal to 0. Now from there, we can identify what A, B, and C are. So A is that 54.5, and again, this is kind of the idea in the quadratic formula itself. Remember I said it has to meet this basic setup requirement first. I know it says x equals, but in our case here, x is now t. So we're just switching out the variables, so that's perfectly safe. We're good to do that. And then once we do that, we're going to plug it all into the equation. Now, please make sure that when you are working your way through this on the quadratic formula, and again, like I said, it's very important here, do what's underneath the radical first before you take the square root, okay? Now, once you have that number, then you can plug it in and take the square root. And if the square root comes out to be nice and pretty, we can continue on and we're going to get an exact answer that's going to be a little bit nicer. But most word problems don't have always the nicest of numbers here, but sometimes it works out. So in this case here, we're going to get two possibilities. So we're going to take 250 plus 840 divided by 109, and then we're going to take 250 minus 840 divided by 109. Again, you're probably asking, where did all this stuff come from? Again, all I did was plug into my quadratic formula. So a negative times a negative 250 plus or minus the square root of a negative 250 quantity squared minus 4 times 54.5 times a negative 2,950, and then all of that was divided by 2 times 54.5. And that's how I simplified it all out. And when I simplified it out, like I said, you have two possible choices that can happen here. And basically, you've got one that is going to have the minus sign and one that is going to have the plus sign. It doesn't matter which one you do first. However, you do need to do both of them. So don't just think you can just get one and be done. You actually have to do both. Now, when I did both, I got x equals 10 and x equals a negative 5.4. Now, I am going to remind myself here that the model's predicting the number of subscribers worldwide, and T is the number of years after 2020. So a negative 5.4 would mean years going backwards, which is not going to work. So we're going to take this one and we're going to rule it out. And we're ruling it out because t cannot be negative in the sense because we're only talking about positively going forward from 2020. So t is 10, and 10 years after 2020 would put it as 2030. Okay, so let's talk about the discriminant. Now, the discriminant is a part of the quadratic formula. It is specifically referring to that part that's called b squared minus 4ac. So the part that's underneath the radical sign. Now, with that being the part that's under the radical sign, there's basically three options that it can be. It can be positive, it can be negative, or it could be equal to 0. Now, if it's positive, that means it's going to be greater than 0. And if that discriminant is greater than 0, then I can guarantee that there will be two real solutions to that problem. Now, if that discriminant happens to be equal to 0, then there's only one answer, and that's going to be that negative b over 2a part, because there's no plus or minus, because it's going to be plus or minus 0. So it's only the negative b over 2a, which means there's only one answer there. Whereas if it is less than 0, so if that discriminant is less than 0, then that means there's no real solutions. Now, just because there's no real solutions doesn't mean that there's a solution. There will still be solutions. They are just no longer real numbers, and they're going to be part of the imaginary number system. So kind of a way to help you visualize that discriminant as well as looking at the graph. When you have, like I said, that discriminant being a positive number, that basically tells us that we're going to have two real numbers, which means it will cross the x-axis 2 times. And again, these are those two real solutions. Now, I suggest for these types of problems that you're going to use maybe the factoring, graphing, or even the quadratic formula. Now, for the parts where it's the discriminant actually equals 0, that is what it's going to look like on the graph, only having touched in one area on the x-axis. Because remember, the discriminant is going to end up being 0, square root of 0, 0. So if I add and subtract 0, I'm still only left with that negative b over 2a. Now, that is, like I said, it's that one solution. And again, I would suggest maybe using factoring, graphing, or even just the square root method. You'll notice I'm not suggesting the quadratic formula. The quadratic formula will still work here, but it might be a little bit easier to deal with the square root method instead of the quadratic formula. Okay, so for the third possible solution, that was where the discriminant was basically a negative number. When you are looking at this one graphically, this is going to basically show you that it doesn't cross the x-axis whatsoever. And this is going to be meaning that there's no x-intercepts that are on the real number system, which is why we say the equation has no real solutions. Now, with that being said, so to make sure that we have the idea there and making sure that we are in the right idea, you're going to need the quadratic formula for this one. Yes, there are a few that you might be able to solve with the square root method, but there's no way for you to do this one with factoring easily. Definitely not. And most people are not going to think of it. So for you guys, I wouldn't recommend factoring whatsoever. And there's no way for you to use a graphing calculator. It's just not going to happen. So you'll have to do these ones by hand when they come across this way. And again, I can kind of have a head start on this if I use the discriminant to kind of let me know what's going on. So let's try the square root method with solving. So x squared equals 9 is my first equation that I want to work there. And again, I know that I want to use the square root method on this one because I basically have stuff equals negative 9. So in this case here, I'm going to take the square root of both sides, and that's going to cancel out the power of 2 on the left-hand side on the x, leaving me with x equals plus or minus the square root of negative 9. Now, for those of y'all that have your calculator and you're saying, it won't take the square root of negative 9. It will not. That is because this is a complex number. So you have to be in the complex number system for this one to work. So for this one, I'm going to have to think of this as plus or minus 3i. Now, anytime I see that -1 underneath the even root radical, we remind ourselves that is nothing more than the imaginary number system, or the complex number system, I should say. So the real name is a complex number system, but we know that the square root of -1 is imaginaries. So that's where the plus or minus, and the square root of 9 is 3, and because it's negative, that's where the I came from. And there's my answer. Now again, if you try to use the graphing calculator on this one, it's not going to help you whatsoever. So for this one, I can also use the square root method. And like I said, this is going to be the other method that I would recommend besides the quadratic formula, but only if it meets this special case. Now, this one and for part A and part B here, they both meet that special case. Now, how do I know why these meet the special case? Is one, they basically have B is 0. And if B is 0, this is why this works so nicely. So we can start by subtracting 24 and then dividing by 3. And again, if you're not sure what I've just done, is I started by subtracting the 24 to the other side, and then I divided by 3. A lot of the times when you see people working their math, especially the higher levels you get, we can't take all the time in the world and show every single individual step. And so you're going to see people doing this a little bit quicker. Now, at this point, we have x squared equals a negative number, which is definitely going to tell me that I'm going to end up with an imaginary number, because we're going to say plus or minus the square root of -8. And that negative underneath that square root symbol is going to come out and become an I. But I also notice 8 is divisible by a perfect square. 8 happens to be divisible by 4. Now, again, if you guys are not sure how I'm able to do this, you're definitely going to want to take a little bit of time and review your radicals, but I know that 8 is the same thing as 4 times 2. Okay, and this is still times that -1 underneath there. So I'm going to take the square root of 4, which is 2. I'm going to take the square root of -1, which is I, and that's why 2 stays underneath. Now there's still a plus or minus in the very front, so the plus or minus stays there as well. Okay, so let's try these ones. So with these ones here, I have x squared minus 3x plus 5 equals 0, and then I have 3x squared plus 4x equals -3. Now, again, I wouldn't use the principle of the square root property on this because b exists, okay? And what I mean by b is existing is this term right here, that minus 3x here, and this term right here, plus 4x there. It's because I have some number directly in front of x. That's going to let me know that I am definitely not wanting to use the principle of square root property. So I'm going to fall back onto my quadratic formula. Now, if I go ahead and put this in the calculator and try to graph it, I can graph the left one. I must do a little bit of work on the right one before that 3x squared plus 4x equals -3. I can't plug that one directly in the calculator because it doesn't say equals 0. But that's kind of where that case is. So we're going to start with the part A one. And part A, again, I'm going to say negative times b plus or minus the square root of b squared minus 4ac all over 2a. So that's going to give me x equals a negative times a -3 plus or minus the square root of -3 quantity squared there minus 4 times 1 times 5. And then all of that is divided by 2 times 1. Now, when I simplify that out, that is going to give me 3 plus or minus the square root of -11, all divided by 2. Now, 11 happens to be a prime number, so it's not divisible by any perfect cube, but I have a negative symbol underneath that radical, which means it's going to come out and become an I, and I'm going to get 3 plus or minus I square roots of 11. I'm going to do my quick check, okay? So I'm going to check my V real quickly, this area right here, okay? And when I check that V area, I notice that 3 and 1i and S2 do not have anything in common, so we're good to go there. Now, if I were to break this apart into the two separate separate answers. Remember, one has the plus sign, one has the second sign. One has a plus and one has a minus sign. It is still technically two different answers. And normally when you see the ones with I written in them, a lot of the times they like to write it in this format. And this format is basically what we call A plus BI format. And that's how we like to write majority of our complex numbers, as this A plus BI format. So what I've done is I basically took 3 and divided by 2. Then I took the square root of 11 and divided by 2. And then I'm going to pull that I and put it in the very back on the outside of the fraction, but it's still considered in the top, but it's basically being multiplied to the fraction. And now it's in that A plus BI mode. And again, one's going to have the plus and the other one's going to have the minus. So let's give a shot at part B. Now, before I can start part B, I have to remind myself that that did not say equal 0. Again, because it doesn't say equal 0, I need to add the 3 over, and then once it equals 0, I can basically now just plug into my quadratic formula, which says negative b plus or minus the square root of b squared minus 4ac all over 2a. So I have a negative times 4 plus or minus the square root of 4 squared minus 4 times 3 all over 2 times 3. Mouthful. Now, when I do what's under the radical first, I'm going to get the square root of negative 20. Again, notice I am not putting the whole thing in the calculator. I'm literally taking it step by step, because if you put the whole thing in the calculator, you're going to get some errors on this one. So we get negative 4 plus or minus the square root of negative 20, all divided by 6. I'm going to remind myself there that 20 can be broken down into that format of a square root of negative 1, a square root of 4, and a square root of 5, because 4 times 5 is 20, times that negative 1, which will give me the negative that becomes part of that negative 20. And that's basically how I'm able to break it down and make this end up being negative 4 plus or minus 2i square roots of 5 over 6. Now, again, I'm doing this because I can pretty much take a peek at this and go, okay, this right here is going to become I. The square root of 4 is 2. And then 5 is a prime number that I cannot take the square root of. So it stays just like that. Everything else is going to stay exactly as is. Now, I am going to make sure that I check my v. So I'm going to check the negative b, and then I'm going to check what's in front of the radical and then what's underneath. If all three of those share something in common, which in our case this one does, I will need to factor out what they have in common. Now, you can factor out by taking the steps individually this way, where you factor out what's common in top and then factor out what's common in bottom, and then you can see that they cancel very nicely. Now, do you have to show that step? Absolutely not. If you can see what all three of them share in common, you can kind of quickly take that step and say, oh, they all share a common factor of 2, and then we're going to get negative 2 plus or minus I square roots of 5 all divided by 3. Okay? Again, you're still going to have the two different answers there, and make